Welcome back. I hope you had a great break. Just want to make sure that you're aware we're on section 12, 2 notes, and your EOC review tonight is question number 1. It says perform the following composition of transformations for this segment PW, and this must be done on graph paper, so I need to see it on graph paper. And remember that you do the inside first and you do the dilation second. We are going to summarize the relationships that you saw and discovered Friday before Thanksgiving break. And these are going to be relationships between central angles and diameters and right angles and radii and tangents and all sorts of good stuff. So we defined the chords of a circle on Friday to be a segment whose endpoints are on the circle. That CD was an example of a chord. CE was an example of a chord because the endpoints are on the center or on the circle. HG is an example of a chord. BF is the biggest chord in the circle because it's a diameter. It's the largest chord. The ones I'm going to highlight now in blue are not chords because that is endpoint is on the circle and on the center. To be a chord, the endpoints must be on the circle. Again, I is also not a chord. So we're going to summarize the properties of chords that you all discovered. So if two chords in a circle are congruent, then they determine two congruent arcs. In other words, congruent chords have congruent arcs. And that is true if the circles are congruent and the arcs in each one circle is congruent. If two chords in a circle are congruent, then their central angles are congruent. So, congruent chords give us two properties, and these properties you need to know. So we've got this chord and this chord. And I'm telling you that this chord is equal to that chord. If that is true, then you know this arc right here is going to have the same measure as that arc. It will also have the same arc length. Now, if that is the center of my circle, and I were to draw in the central angle, then that means that we know that this angle here is equal to that angle there. And you learned in section 10.6, I believe, or 10.7, that the measure meaning in degrees, of an arc is the same as the measure of its central angle. Now, the length of the arc, that's different. So here I've drawn you a picture. So this is an important piece of information right here. If I see congruent chords, I will look for, and here's my picture. So you need to associate congruent chords with the following. If you see congruent chords, then you look for equal arcs and you look for equal central angles. If you know that you have two congruent arcs, then you know the chords they cut off are equal and you know their central angles are congruent. If you're given two central angles, then you know that the chords they cut off by their endpoints where it intersects the circle are congruent and that their arcs are congruent. So this is a lot of information. Congruent chords mean congruent central angles and arcs. Congruent arcs means congruent chords and congruent central angles. Congruent central angles means congruent chords and congruent arcs. So this is an important piece of the section. And this is where I try to take a lot of different theorems or relationships and try to get them into something that's easy to see. All right, E is the center of the circle. We've got AB congruent to DC. So right there you see two congruent chords. When you see congruent chords, that should tell you to look for two congruent arcs, and you should look for two congruent central angles. So I haven't even looked at what the problem's going to ask us to do. What I'm going to do is I'm processing this right now, and I'm going to say, what do I know? I know that the central angle that this chord cuts off is angle 1, and the DC cuts off angle 2, and I know they're congruent because the chords are congruent. I also know that this arc right here is congruent to that arc right there. Now that doesn't mean that that arc's going to be congruent to that arc. As you can tell, it's not. So let's look and see what they gave us. They told us that the measure of arc AB is 40 degrees. If this is 40 degrees, then that means the arc DC is also going to be 40 degrees. But let's do some more. If that's 40 degrees, the measure of a central angle whose vertex is on the center is also 40 degrees. If this is 40 degrees, then its central angle is also 40 degrees. So I could have asked you for the measure of angle AEB on this instead of arc DC. I could have asked you for the measure of angle DEC instead of the arc that I asked you for. All of those could have been requested in the same one. All right, so I'm going to come back here and I'm going to erase what was from the first problem. All right, my arcs are still, these are still congruent. All right, so now what do we have? We have angle 1 is 88. Here is angle 1. If this is 88 degrees, then the measure of a central angle is equal to the measure of its arc. So now I've got congruent chords, which means I have congruent arcs, and because that arc is 88 degrees, that means angle 2 is also 88 degrees. So I've asked you for CD, which is 88 degrees. I could have also asked you for the measure of arc AB, or I could have also asked you for the measure of angle 2. These are not vertical angles because you can see those segments are not, do not form a nice tight X. All right, so now E is the center of the circle. So now we've been told that angle 1 is congruent to angle 2. So what do I have? I have two congruent central angles. So before I look at any problems, what does that tell me? That means that I should look for two congruent arcs, and I should look for two congruent chords. All right, so they're telling us that in the measure of angle or of arc, BAD is 215. So I start at B, I pass through A, and I go to D. This from here all the way over to there is 215. Now they told us that the measure of angle 2 is 120 degrees. Because 1's congruent to 2, I know that angle 1 is 120 degrees. So I want to find arc AD. So if this is 120 degrees, then I know its central angle, or its arc that it cuts off, is 120 degrees. So if the whole thing is 215, then I know if I take 215 and I subtract 120, I am going to end up, notice I'm showing work just like I asked you to do. I know that 11, 19, okay. Our measure of arc AD has to be 95 degrees. All right, so just looking at this, if I know the measure of angle 1 is 120, I know the measure of angle 2 is 120 because they told me that. I know the measure of arc DC is 120. I could have also asked you for that. All right, so I'm going to come up here. I'm going to erase what we just did. And now we're going to look at some algebra. And you know how I love algebra. All right, again, they told us that angle 1 is congruent to angle 2. They're telling us that arc AB is 6x minus 1. They're telling us that arc CD is 3x plus 20. If you have two equal central angles, then that means arc AB in green is going to be the same measure as arc BC in green. So that should be what tells you how to write the equation of this to solve for angle 1. So that means that 6x minus 1 should equal 3x plus 20. So you're going to subtract 3x from both sides. So you're going to end up with 3x minus 1 equals 20. We will add 1. So we're going to get x is equal to 7. Now from here, this is great that we found x, but they always ask for more. We need the measure of angle 1. When we know the measure of angle 1 is the same as the measure of that arc that it cuts off, which is AB. So the measure of angle 1 is 1. That's not a very good one. The measure of angle 1 is going to be 6 times 7 minus 1, or 42 minus 1, or 41 degrees. All right, so now let's look at this picture. We know that this chord is equal to this chord. As soon as you see those equal chords in your mind, you should say, oh, look at this. I've got two equal arcs. So I don't know the arc on the left, but I do know the arc on the right. And the arc on the right is 80 degrees, which means that this should also be 80 degrees. We know that all the degrees in a circle is 360. So if I start here and I go all the way around to this point, that if I take 360 and subtract that, I'll have what I need. I'm going to write I've got 80 degrees plus 110 degrees plus 80 degrees plus x degrees is equal to the degrees in an entire circle. So this shows me concepts, so if you make a careless error, I'll be able to follow what you do. You get more partial credit. So we've got 0, 7, 270. So I've got 270 plus x is equal to 360. We're going to subtract 270. So it looks like x is going to be 90. So if x is 90, they should have told us that this is the center of a circle. This arc is equal to this measure of its central angle. Therefore, y must also be 90. All right, here is a U-try. They have told us that angle ETR is 4x plus 3, and they have told you the measure of WQ is 2x plus 71. They want the measure of arc ER, and that means they want it in degrees. So I would ask that you pause and do number 1. Take about 3 minutes to get that equation set up. So now we're going to summarize the second investigation you did, and it says in a circle, if a diameter is perpendicular to a chord, and I just want you to be aware of that it could be a radius because a radius is part of a diameter, then it bisects, that means cuts in half, the chord and the arc. So we've got a diameter, and again, it could be something as simple as a radius. If you see that box, the right angle box, that's perpendicular. That means the chord is equal to that half, and then this arc is equal to that arc. All right, what else did we learn? In a circle, if a diameter or radius bisects the chord, so now what they're telling us is that this chord has been bisected, then it is perpendicular to the chord. And because it's perpendicular, it is perpendicular to the chord, then the other theorem up here that we just talked about goes into play, and we know then that that arc is equal to that arc. All right, so now let's look. So here's a summary. If I see a radius or a diameter perpendicular to a chord, what am I going to look for? I'm going to look for equal segments, and I'm going to look for equal arcs. So as you can see, what we're supposed to be looking for is that perpendicular relationship. That summarizes this in a nutshell. All right. So D is the center of the circle, and BD is perpendicular. Notice they didn't show you the box, put the box, to chord AC. So now, what does this tell me I should look for? I see a radius perpendicular to a chord. I should look for equal segments, and I should look for equal arcs. So I notice I didn't even look at my problems. I'm going with what I've been given. These two arcs are equal, and this segment is equal to that segment. So they're telling us now, let's go to a problem. If the measure of arc BC, that means this arc right here is 70 degrees, find the measure of arc AB. So because the perpendicular relationship, and this goes back to a theorem we had a long time ago. This is a perpendicular, this is a radius, and this is a radius. So if we know that we've got two segments that are congruent, then it must be on the perpendicular bisector of the segment. So we know that AB is automatically 70 degrees. But how else could I have framed this question? I could have asked you for the measure of arc AC, at which point it would have been 70 plus 70, or 140. You could have done 2 times 70. All right, so now I'm going to erase what we just did, and we're going to go to the next one. So now we're being told that the measure of arc A pass through F, stop at C, is 300 degrees. So if this arc is 300 degrees, then we need to be able to find the measure of arc BC. So if that's 300, we know that there's 360 degrees in a circle, and that means that this arc A to C is 60. So if A to C is 60, that means this must be 30, this must be 30, and now we need to find the measure of angle 2. And if you recall, if I have the measure of an arc, it's equal to the measure of its central angle, which means the measure of angle 2 is equal to 30. How else could I have asked this question? I could have asked you for the measure of angle 1. Or I could have asked you for the measure of angle ADC. ADC, this is 30, this is 30, therefore that measure would be 60. So these are all different ways that you could see this on your worksheet, all different ways that you could see this on a... All right, so I'm going to get rid of this. And now we're going to look at the next one. So this last problem took in like section 10.7, a lot of stuff that we've had in the past. All right, so now I've got the measure of angle 1 is 44 degrees. All right, I need to erase some more. So measure of angle 1 is 44 degrees. So if I know this is 44 degrees, I didn't look to see what I'm looking for. I know that if this is perpendicular, that it bisected the segment, it bisected the angle, so this is 44, which makes this 44, which makes this 44. So they want the measure of arc C, F, C, passes through F, goes all the way over to A. So as you can see, if you look at the sum of these two, that is going to be 88. So 88 degrees is what's there. So if I take my whole circle of 360 and I subtract 88 degrees, then I'm going to have 282 degrees for this arc on the rear in green. Then here's D is the center of a circle. DB bisects AC. So the first one we did, I think I tried to give you something on each one. The first one we did is I gave you congruent angles, central angles. This time, I gave you the perpendicular. So D is the center. DB, if DB bisects AC, because this is equal to this because they are radii, then that means that this is going to be perpendicular. And again, this arc is equal to this arc. This segment is equal to that segment. So now we're going to go into algebra. If arc BC is 6x minus 1, and arc AB is 4x plus 19, then the equation I'm going to write is 4x plus 19 equals 6x minus 1. I'll subtract 4x from both sides, and I'll have 19 is equal to 2x minus 1. I'll add 1, and I'm going to get 20. Then I divide by 2, and I have 10. Now, we want the measure of angle ADC. ADC is the whole thing. So, I know that arc BC and angle 2 are the same measure. I know that arc AB and angle 1 are the same measure. So, it doesn't really matter because I know that those two angles are congruent. So, I'm going to go ahead and do the measure of angle 1. The measure of angle 1 is going to be 4 times 10 plus 19, which is going to be 40 plus 19, which is going to be 59. So if angle 1 is 59, and therefore angle 2 is 59, so if I want the whole angle, the measure of angle ADC is going to be 2 times 59, which is going to be 118 degrees. I just want to make a statement because this is like the, we can play with this like the midpoint. I'll write another problem in a minute. So let me go ahead and do this next problem. I'm going to erase all this stuff. We are told that AC, this whole thing right here, that segment is 16. If this whole segment is 16, that means that that segment is 8, and this segment is 8. DC is 12, this is 12, we want the length of ED. Now we're given segments, not angles. I'm looking for this segment right there. And if I were to trace this in a different color, I don't want green, so let me undo that. If I were to trace this triangle, what we've got is we've got Pythagorean theorem. We would say leg squared, which is x squared, plus my other leg squared, which is 8 squared, equals 12 squared. From here, we would say x squared plus 64 equals 144. Then you're going to subtract 64 and get 80. And then remember, when we square root, we always get two answers, a positive and negative, and that's for Algebra 2. If I don't see that, I will not give you credit. So square root of 80 is what we need to do, and the square root of 80 is going to be approximately 9.9. Actually 8.9. So this is approximately 8.9. So again, Pythagorean, remember I said Pythagorean will be in the mix in a lot of these problems. So now we've got DB bisects AC. So now I'm telling you angle 2 is x plus 1. And I'm telling you the measure of this whole arc is 4x minus 22. So when this segment is bisected, that means this is perpendicular, which means this arc is equal to that arc. And the measure of an arc is equal to the measure of its central angle, which means that's x plus 1. If that's x plus 1, then this is x plus 1. So this would be actually arc addition, believe it or not. We had segment addition, angle addition. X plus 1 plus x plus 1 is equal to 4x minus 22. So you've got to draw a picture and you've got to make sure these are not equal. And if you set them equal, then you are not paying attention. So we've got 2x plus 2 is equal to 4x minus 22. I'm going to subtract 2x from both sides. I'm going to add 22 to both sides. So I'm going to have 24 is equal to 2x, or x is equal to 12. They want us to find the measure of arc BC. BC is right here. So the measure of that arc is going to be my x, which is 12 plus 1, which is 13. And that is 13 degrees because the measure of an arc is in degrees. Arc length is in centimeters. So here is a U try. If there's time in the period, it would be great if the kids could do this. the last investigation you did, which would have been investigation 6, talked about these segments here in the center. It says, within a circle or congruent circles, chords equidistant from the center or centers within a circle or congruent circle, chords equidistant from the center or centers are congruent. And the converse would be within a circle or congruent circles. If you have congruent chords, then they are equidistant from the center. So let's kind of dissect this word equidistant. There's equa and there's distant. All right? So if we take this apart, this means equal, distant means length, or equal distances. So within a circle or congruent circles, chords equidistant from the center. That means if this segment is equal to this segment, and when we say equidistant, we're meaning the shortest length, and equidistant always comes with it a perpendicular. So if this segment is equal to that segment, then we can conclude that segment CD is congruent to segment AE. So if you know that this chord is the same distance from the center as that one, and again, equidistant, the relationship will be perpendicular because that's the shortest distance. If you know that, then the chords are congruent. So let's look at the second one. So now we're being told that this segment CD is already congruent to AE. Then the conclusion is that these chords are equidistant from the center. So in that case, we conclude that those segments are congruent. All right, so if I see chords that are equidistant from the center, I will look for equal chords. So this is what you see. You see that from the center of the circle to a chord, if that segment distance is the same as that distance, then you know that those chords are congruent. So two congruent chords, this is a summary, all right? Two congruent chords determine two congruent arcs, determine two congruent central angles, and are equidistant from the center. If you know this is all you know, you've got all that information. So if I know that the measure of angle ACB is 65. Oh, I just did that wrong. Oh, see, it doesn't tell me anything. Here we go. Let's try this again. If the measure of angle ACB is 65, then, and these two chords are congruent, then I know arc AB is 65, and congruent chords have congruent central angles, and they have congruent arcs. So I know the measure of arc AB to be 65, I know the measure of arc ED to be 65, and I know the measure of ECD to be 65. Okay, that's just a review that's putting together. So now we've got this perpendicular relationship. So now that we know that AB is congruent to ED, AB congruent to ED, we've got the perpendicular relationship. Because chords are congruent, we know that the major angles are congruent and these major arcs are congruent. But the perpendicular now splits these segments, so they're equal. It makes these two arcs equal, and therefore, because the big arcs AB was equal to ED, those are congruent, and then ACB and ECD are going to be congruent. So if AB equals 16, AB, the whole segment, is 16, then I know this is 8, and I know this is 8. They want to know what is the length of AH. AH is 8. If they told us that the measure of angle ACB, the whole angle, is 44, then what is the measure of this arc? So if this is 44, I know this is 22, and I know this is 22, which means that is 22. If CK equals 6 and AC equals 10, find ED. All right. So I'm going to erase everything off this picture because this is where they are trying to confuse you. Here we go. We know, let's go back. We're given that these two chords are congruent and we're given the perpendicular relationship. So we know this is congruent to this. We know that is congruent to that. Congruent chords, congruent. This is going to be, they got bisected, so those parts are equal. I know this arc is congruent to that arc, and because our arcs were congruent, those are congruent. What else do I know? I know the segment from H to C and the segment from C to K are congruent because congruent chords are equidistant from the center. Now, something that maybe we didn't think about, and this is something that you're going to have to recognize, AC, BC, EC, and CD are all radii. And radii in a circle are always going to be the same. So if they tell us that AC is 10, that means that BC is 10. That means that DC is 10. And that means that EC is 10. So when they tell us that CK is 6, and they want this whole length, we can write an equation where this DK is X, working with only this triangle right here, which is a right triangle. And the Pythagorean theorem, we would say 6 squared plus x squared is equal to 10 squared. 36 plus x squared equals 100. Subtract the 36, we get 64. Square root both sides, we get plus or minus 8. And what we're going to choose is the positive 8. So if this segment is 8, then this segment must be 8, which means ED is 16. Well, if that segment's 8, and that segment's 8, and that segment's 16, we know this segment is also 16, so this is also 8, and that's also 8. So now F is the center of circle O, and they're telling, again, we have congruent chords. If these chords are congruent, then we know that these two distances are congruent. So if EF is 5x minus 7 and FG is 2x plus 11, then the equation rewrite is 5x minus 7 is equal to 2x plus 11. And then you solve for x. I think I'm getting, all right. So we would subtract 2 and we would have 3x minus 7 equals 11. We would add 7 and we'd get 18. So x is 6. All right, so now what are they going to tell us? They are going to tell us that CD, this whole thing is 20. So that means that this part is 10 and this part is 10. CF is not drawn. Let's draw it in. CF is 15. That is a radius. And they want you to find FG. Well, we know FG is what we want to look for, but we know that it's the same as EF. And if you look at this triangle right here, I know that side. Don't know that side, but I do know that side. So if we use Pythagorean theorem, we'll have 10 squared plus x squared equals 15 squared. So we have 100 plus x squared equals 225. Subtract 100, you get 125. Now we're going to administer the square root here. Square root here, we get 2 answers. We will choose the positive. And if I take 125 and square root it, I'm going to get 11.18, and we choose the positive one. And that is the end of the lesson for today. So if you would like to go back and have the kids try this, that would be great. hope to see you tomorrow. I want to mention that your exam review is already posted online if you're interested.